Electrical interference can cause smoke alarm malfunctions, so verify that the alarm is not on the same circuit as any noisy appliances, for example, refrigerators, motors, generators, or fluorescent lighting. These can generate electrical noise that may interfere with the alarm. Try isolating the alarm on a dedicated circuit. Loose wiring can also cause intermittent electrical faults and false alarms. Check if the wiring connections to the alarm are secure. Tighten all connections and ensure there is no arcing. Incorrect polarity can cause erratic behavior. Ensure the battery is installed with the correct polarity, positive and negative terminals aligned. If the alarm continues to malfunction after replacing the battery and checking wiring connections, it may be defective. Contact the manufacturer or replace the unit. Environmental factors can also affect sensor performance. Extreme temperatures, high humidity, or dusty environments can affect sensor performance. Ensure the alarm is installed in a clean, dry, and temperature-controlled area. Nearby radio frequency interference can also be a factor. Some electronic devices emit radio frequency signals that can interfere with smoke alarms. Move the alarm away from any devices that could potentially emit radio frequency, such as cell phones, Bluetooth speakers, or Wi-Fi routers. Arc fault breakers are designed to detect electrical arcing and trip to prevent electrical fires. In some cases, an arc fault breaker may be overly sensitive and trip even when there is no real fault. Try replacing the arc fault breaker with a standard circuit breaker to determine if it resolves the issue. Dimmer switches can introduce electrical noise onto the circuit. If possible, remove the dimmer or move the alarm to a different circuit without a dimmer. Test the alarm regularly using the test button to ensure it is functioning properly. Replace batteries annually to avoid weak batteries that may cause false alarms. Contact a licensed electrician if you suspect any electrical issues that may be causing the problem. Consider electrical interference from various sources firstly. Noisy appliances such as refrigerators, motors, and generators can introduce electrical noise into the circuit, potentially triggering false alarms. Fluorescent lighting can also be a source of interference. Isolating the smoke alarm on a dedicated circuit can minimize the impact of these external electrical disturbances. Secondly, loose wiring can lead to intermittent electrical faults, resulting in false alarms. Thoroughly inspect all wiring connections to the smoke alarm, ensuring they are secure and properly tightened. Look for any signs of arcing, which indicates a loose connection. Rectify any wiring issues promptly to prevent further malfunctions. Thirdly, incorrect battery polarity can disrupt the smoke alarm's functionality. Double-check that the battery is installed with the correct polarity, aligning the positive and negative terminals as indicated. Improper battery installation can lead to erratic behavior and false alarms. Fourthly, a faulty alarm unit may be the root cause of the problem. If the smoke alarm continues to malfunction despite addressing other potential issues, it may be defective. Contact the manufacturer to inquire about warranty options or consider replacing the unit with a new one. Fifthly, environmental factors such as extreme temperatures, high humidity, or dusty conditions can affect the smoke alarm sensor performance. Install the alarm in a clean, dry, and temperature-controlled environment to minimize the impact of these factors. Sixthly, radio frequency interference from electronic devices can disrupt smoke alarm operation. Common sources of radio frequency interference include cell phones, Bluetooth speakers, and Wi-Fi routers. Move the smoke alarm away from these devices to mitigate potential interference issues. Seventhly, arc fault breaker sensitivity can sometimes cause false alarms. Arc fault breakers are designed to detect electrical arcing, but they may be overly sensitive in some cases. Consider replacing the arc fault breaker with a standard circuit breaker to determine if it resolves the problem. Eighthly, dimmer switch interference can introduce electrical noise onto the circuit. Dimmer switches are known to generate electrical noise which can trigger false alarms and smoke alarms. If possible, remove the dimmer switch or relocate the smoke alarm to a different circuit without a dimmer. Testing the alarm regularly by using the test button ensures that it is functioning properly. Replacing batteries annually avoids weak batteries that may cause false alarms. Consulting a licensed electrician if you suspect any electrical issues that may be causing the problem will help resolve the problem. Electrical interference can emanate from various sources within a building's electrical system. This interference can manifest as voltage spikes, harmonic distortions, or electromagnetic noise, which can disrupt the delicate circuitry of a smoke alarm. Firstly, appliances with motors, such as refrigerators, air conditioners, and washing machines, are notorious for generating electrical noise when they cycle on and off. These appliances can introduce voltage fluctuations and harmonic distortions into the electrical system, potentially triggering false alarms in smoke detectors. Secondly, fluorescent lighting, especially older models, can also be a source of electrical interference. Fluorescent lamps utilize ballasts to regulate the current flow, and these ballasts can generate electromagnetic noise that can interfere with the operation of smoke alarms. Thirdly, electronic devices, such as computers, televisions, and audio equipment, can also contribute to electrical interference. These devices often incorporate switching power supplies that can generate high-frequency noise that can propagate through the electrical system. To mitigate the effects of electrical interference, it is advisable to isolate smoke alarms on dedicated circuits, separate from circuits that power noisy appliances or electronic equipment. This can help to minimize the amount of interference that reaches the smoke alarm, reducing the likelihood of false alarms. Loose wiring can create intermittent electrical faults, leading to erratic behavior and false alarms in smoke alarms. When wiring connections are not properly secured, they can become loose over time due to vibrations, temperature changes, or corrosion. Firstly, loose connections can create a high resistance point in the circuit, which can generate heat and potentially lead to arcing. Arcing is a phenomenon where electricity jumps across a gap in the circuit, creating a spark. This arcing can generate electromagnetic interference that can trigger false alarms in smoke alarms. Secondly, loose connections can also cause intermittent voltage drops, which can disrupt the operation of the smoke alarm's internal circuitry. These voltage drops can cause the smoke alarm to malfunction or trigger a false alarm. Thirdly, loose connections can also create a safety hazard, as they can lead to overheating and potentially start a fire. Therefore, it is essential to ensure that all wiring connections to smoke alarms are properly secured and tightened. This includes checking the connections at the smoke alarm itself, as well as the connections at the electrical panel and any junction boxes in between. Incorrect battery polarity can prevent a smoke alarm from operating properly, or it can cause it to malfunction and trigger false alarms. Smoke alarms are designed to operate with a specific voltage and polarity. When the battery is installed with the correct polarity, the positive terminal of the battery is connected to the positive terminal of the smoke alarm, and the negative terminal of the battery is connected to the negative terminal of the smoke alarm. Firstly, installing the battery with the incorrect polarity can damage the smoke alarm's internal circuitry. The reverse polarity can cause excessive current flow, which can overheat and damage sensitive components. Secondly, incorrect battery polarity can prevent the smoke alarm from operating properly. The reverse polarity can disrupt the flow of electricity through the circuit, preventing the smoke alarm from detecting smoke or triggering an alarm. Thirdly, incorrect battery polarity can cause the smoke alarm to malfunction and trigger false alarms. The reverse polarity can cause the smoke alarm to generate erroneous signals, which can trigger the alarm even when there is no smoke present. Environmental factors can significantly affect the performance of smoke alarms, leading to false alarms or reduced sensitivity. Firstly, extreme temperatures can affect the accuracy of the smoke alarm sensor. High temperatures can cause the sensor to become less sensitive, while low temperatures can cause it to become more sensitive. This can lead to false alarms or a delayed response to actual smoke. Secondly, high humidity can also affect the sensor. High humidity can cause condensation to form on the sensor, which can interfere with its ability to detect smoke particles. Thirdly, dusty environments can also pose a challenge for smoke alarms. Dust particles can accumulate on the sensor, reducing its sensitivity and potentially triggering false alarms. Fourthly, insect infestations can also affect the smoke alarm's performance. Insects can crawl inside the smoke alarm and build nests, which can interfere with the sensor and trigger false alarms. Radio frequency interference can disrupt the operation of smoke alarms, causing false alarms or reduced sensitivity. Smoke alarms rely on electronic circuits to detect smoke particles and trigger an alarm. These circuits are susceptible to interference from radio frequency signals, which can disrupt their operation. Firstly, cell phones emit radio frequency signals that can interfere with smoke alarms. When a cell phone is used near a smoke alarm, the radio frequency signals can induce currents in the smoke alarm circuitry, potentially triggering a false alarm. Secondly, Bluetooth devices also emit radio frequency signals that can interfere with smoke alarms. Bluetooth speakers, headphones, and other devices can generate radio frequency noise that can disrupt the operation of the smoke alarm. Thirdly, Wi-Fi routers and other wireless devices can also be a source of radio frequency interference. These devices emit radio frequency signals that can propagate through the air and interfere with the smoke alarm circuitry. Arc fault breakers are designed to protect electrical circuits from dangerous arcing faults. Arcing faults occur when electricity jumps across a gap in the circuit, creating a spark. These sparks can generate heat and potentially ignite flammable materials, leading to a fire. Arc fault breakers are designed to detect these arcing faults and quickly trip the circuit, preventing a fire from starting. Firstly, arc fault breakers can be overly sensitive and trip even when there is no real arcing fault. This can be caused by normal electrical noise in the circuit, or by certain types of appliances that generate arc-like signals. Secondly, arc fault breakers can also be damaged by surges or other electrical events. This damage can cause the breaker to trip prematurely or fail to trip when there is a real arcing fault. Dimmer switches can introduce electrical noise onto the circuit, which can interfere with the operation of smoke alarms. Dimmer switches work by rapidly switching the current flow to the light bulb on and off. This rapid switching can generate electrical noise, which can propagate through the electrical system and interfere with other devices, including smoke alarms. Firstly, dimmer switches can generate harmonic distortions in the electrical system. Harmonic distortions are additional frequencies that are added to the normal 60 Hz alternating current waveform. These harmonic distortions can interfere with the smoke alarm circuitry, causing it to malfunction or trigger a false alarm. Secondly, dimmer switches can also generate electromagnetic interference. Electromagnetic interference is a form of energy that can disrupt the operation of electronic devices. Dimmer switches can generate electromagnetic interference that can radiate through the air and interfere with the smoke alarm sensor. Testing the alarm regularly using the test button is an important step in ensuring that it is functioning properly. The test button simulates the presence of smoke, triggering the alarm to sound. This allows you to verify that the alarm sensor, circuitry, and siren are all working correctly. Firstly, testing the alarm regularly can help you identify any potential problems early on before they become more serious. If the alarm fails to sound when you press the test button, it could indicate that the battery is weak, the sensor is faulty, or there is a problem with the circuitry. Secondly, testing the alarm can also help you familiarize yourself with the sound of the alarm, so you will be more likely to recognize it if there is a real fire. Replacing batteries annually helps to ensure that the smoke alarm has sufficient power to operate properly in the event of a fire. Smoke alarms rely on batteries to provide power to the sensor, circuitry, and siren. Over time, batteries can lose their charge, reducing the smoke alarm's ability to detect smoke and sound an alarm. Firstly, replacing batteries annually can help prevent the smoke alarm from malfunctioning due to a weak battery. A weak battery can cause the smoke alarm to chirp intermittently, or it can prevent the alarm from sounding altogether. Secondly, replacing batteries annually can also help extend the life of the smoke alarm. A weak battery can put a strain on the smoke alarm circuitry, which can shorten its lifespan. Consulting a licensed electrician if you suspect any electrical issues that may be causing the problem is a wise decision. Licensed electricians are trained and qualified to diagnose and repair electrical problems safely and effectively. Firstly, a licensed electrician can inspect the wiring in your home to identify any potential hazards, such as loose connections, damaged wiring, or overloaded circuits. These hazards can increase the risk of electrical fires and other electrical problems. Secondly, a licensed electrician can also test your electrical system to ensure that it is functioning properly. This includes checking the voltage, current, and grounding of your electrical system. Thirdly, a licensed electrician can also install or repair electrical components such as smoke alarms, circuit breakers, and outlets.